So this is question number 2, and from KCET paper it is question number 12. The Lagrangian equation of motion for a simple pendulum is. So in these 4 options, so we should find out which one is the equation of motion for of Lagrangian for simple pendulum. Okay. So what is simple pendulum? See, let us consider a small rod. For the small rod, let us, a bob is connected with a small frictionless wire. Now the bob is oscillating like this. Okay, it has some simple harmonic motion. Now we should write a kinetic energy and potential energy. We know that the Lagrangian is nothing but L is equal to T minus V. We should calculate the kinetic energy and also we should calculate the potential energy. So when the bob is connected, let us consider a angular displacement of the bob of the simple pendulum is theta. Okay, that means it has some angular displacement. It has some angular displacement theta. Okay, so and the arc of this is S, which this theta is very small. Then the arc, or from the trigonometric relation we know that sin theta is equal to opposite by hypotenuse, which is equal to, what is opposite? S. It looks like a straight line. Okay, so S divided by hypotenuse is nothing but L. Let us consider L is the length of the bob. Okay, that means from the rod to the bob is L. So L, then sin theta is equal to S by L. If theta is very small, so then sin theta is approximately equal to theta. So therefore theta is equal to S by L. Okay, and let us consider, we know that velocity is nothing but ds by dt, right? Next, so therefore v is equal to, what is S from this relation? S is nothing but L into theta. So therefore d of L theta divided by dt. So then v is equal to, differentiate, L is constant, it is not changing. So L into d theta by dt. So we can write this as v is equal to L into theta dot. So this is the velocity of this bob. Okay, when there is a small displacement, angular displacement takes place. This L theta is that L into theta dot is nothing but angular velocity. It has some angular velocity. Okay, so now, so let's see. Therefore kinetic energy T is equal to of m, and that V is nothing but L into theta dot square. So this is kinetic energy. So then what is potential energy? See, so let us consider a bob which makes some angle theta. Okay, so let us draw a perpendicular line to this vertical axis. Let us consider this is y axis. Okay, and we know that the potential energy V is nothing but mgh. Height, we should calculate, we should find the height, but at equilibrium we know that potential energy V is equal to 0 if the bob is exactly at the equatorial. That means, if suppose, let us consider this is the point O. At this point O, okay, so let us consider this is the position of a bob. So here now in this situation there is no potential energy, it is at rest. When the moment the pendulum is start moving, it has some potential energy, it gains some potential energy because it moves opposite to the gravitation of earth gravitation. So it has some gravitational field, it feels some gravitational force. So now it has some potential energy. We should calculate that. So that is, now we should calculate the potential energy here. Let us consider this is the position A, but we should resolve this position A to the vertical axis. So then this distance is B. If suppose this is B, we should calculate this distance OB. So we know that OB, this OB is equal to O. For example, let us consider this is C. So then OC minus BC. So then OB is equal to, what is OC? OC is nothing but length, actual length. So the length of the pendulum. Next, L minus. So what is BC? We should calculate BC. So we know that from this triangle, okay, so from this right angle triangle, if this is theta, this is C, this is B, if this is A, then cos theta is equal to, adjacent side is BC, BC divided by hypotenuse is L, then BC is equal to L cos theta. Therefore BC is equal to L into cos theta, so which is L cos theta, right? So therefore OB is nothing but, if we take L as a common, 1 minus cos theta. So this is H, that means this OB, this is H. Therefore the potential energy V is equal to mg, the potential energy V is equal to mg, H is nothing but L into 1 minus cos theta. So this is kinetic energy and this is potential energy. We know that L is equal to T minus V. So we should substitute here. Then see, L is equal to, kinetic energy is of m L square theta dot square and minus mgl into 1 minus cos theta. So this is Lagrangian for a simple pendulum. Now let us to find the equation of motion for a Lagrangian. So that is dou L by dou T, dou by dou T of, see, this dou L by dou theta dot into d by dt minus dou L by dou T, which is equal to 0. So this is the equation of motion. Now therefore what is dou L by dou theta dot? So dou theta dot here, differentiate with respect to theta dot. So then we will get 2 cancel. So m into L theta dot d by dt you will get after differentiating this with respect to theta dot. Now differentiate this with respect to dt, d theta. Then so here if I multiply mgl here there is no theta coefficient, so this will be 0, and differentiate this, minus into minus plus, and again here we have minus, so minus, and if we differentiate this L with respect to theta and it cos theta, so we know that differentiation of cos theta is nothing but minus sin theta. So again it will be plus sin theta, which is equal to 0. Because differentiation of cos theta is nothing but minus sin theta. So and again see, differentiate this again with respect to t, so then you will get ml theta double dot plus sin theta. So then theta double dot is equal to minus sin theta divided by ml. So okay, sorry, and also I forgot to write this mgl coefficient. So plus mgl, and so this is mgl. Therefore here we will get mgl, and ll cancel and mm cancel. Theta double dot is equal to g sin theta, and also sorry, this is L square. So then here we will also get L square, and denominator will get L. So theta double dot is equal to g by L into sin theta. So is there option? In the option they are given it as L as E. So which one is correct? Option A is correct, right? So this is an equation of motion for a simple pendulum.